AQUABIZ, all the best knowledge for aquatic system.
We need to remove it and move forward as we can. So we've already seen this, so we'll skip through that. But right now there's a lot of emphasis on sustainability. We had a nice talk on sustainability of soy. And to me, I take that more as recycling of nutrients because I think that's really what's driving a lot of this in terms of how well we can take products and recycle them, have no waste coming out. But whether or not you want to put it on a social, economic, however you want to put sustainability. If you look at some of the drivers, as you increase density, so this is a log scale of density, but as you go from low density to high density, and it happens very quickly, you move from the farm having an effect to all of the effect, or most of the effect, is coming from the feed and the feed ingredients. And so if the farm wants to change their footprint in terms of land, water, and energy use, basically it's being driven by the feeds, and so consequently the feed mill manufacturer, has to change how you're doing things. This is an example for Ecuador, and our water includes salt water. So if you take out the salt water, again, the feed is the vast majority of that. But if you look at embodied nutrients, 62% that's coming from the feed. If we took 50% of the energy is coming from the feed, and about 60% of the water use is coming from the feed. So the feed really drives these things, and that's one thing that we have to be wary of, is that there are some choices in terms of sustainability, in terms of how we're going to select feed ingredients in the future. And that, of course, if you look at, as I said, world production, and as I said, there's this continual decrease of the availability of nutrients in the world. A lot of our production is keeping up with things, and just as an emphasis that agriculture is pretty sustainable, and I'd fight back against unsustainable comments about our production. But if you look at land use for cereal grains, it hasn't changed a whole lot. There's our population, then there's our cereal yields and production. So agriculture has been very good about expanding performance of our grains. My understanding is that rice is probably the only one that really hasn't gotten that increase. That's been through increase in land use. If we look at those cereal grains that we're using, milo, corn flour, wheat, rice, other products, we do have some good numbers in terms of digestibility. We have good numbers out there in terms of the effects. This is extrusion processing and the effects dry versus wet. But those cereal grains are a key component of our feed formulations in terms of what's happening, I think, is that we're probably going to be shifting from whole grains to more byproducts, right? So I don't know, how easy is it to get wheat here right now, whole wheat? Piece of cake? I see some people shaking their head. I don't know. Last year I couldn't get it at the grocery store or from the suppliers that I normally get it from. So, this is because of a lot of factors. But, as the availability of ingredients comes down, agriculture is going to move more and more towards those byproducts. So I think that we're going to probably move more towards higher levels of inclusion of byproducts. But the problem there is, as we do move that way, that means we increase amount of fiber, non-starch polysaccharides, some of the not so good things that are found in those products. And that means that we're going to have a lot more fiber. That means we're going to have a lot more phytate. a lot more issues as we move that way. When we're talking about plant-based proteins, of course, all protein sources, doesn't matter if you're talking fish meal, meat and bone meal, poultry meal, or plant-based ingredients, they all have advantages and disadvantages. But as we increase and move towards these plant-based ingredients, of course, that means we have to deal with the imbalances that are caused by that. So you start with fish meal, it's over-formulation, and now we're going towards plant-based ingredients, which are under-formulating, so it's very important that we deal with the issues associated with that increase in plant-based ingredients. So you tend to move towards more ingredients as you move away from these high-quality ingredients. We bring in more anti-nutrients, so non-starch polysaccharides, the presence of phytate. We tend to reduce our level of essential highly unsaturated fatty acids. Now, linoleic, linolenic, to me, DHA is probably the one that's the most hard to get into a feed formulation if you're not using marine protein sources. And then also trace minerals. Forget that a lot of these animal-based protein sources are bringing in our trace minerals. Our fish meal, our animal protein is bringing in cholesterol for our shrimp, right? So it makes it a lot more difficult to balance our feed formulations, and we need to be a lot more precise, and we need to work on our numbers for feed formulations. So if you look at, just as an example, plant-based ingredients, as we increase them, non-starch polysaccharides are going to increase, right? If you look at phytate as the beginning, it's there in that seed for germination. So its job is to chelate things, to grab molecules and hold on to them until the plant starts to germinate. We do have different proteins, different genetics that are low in phytate. We have different genetics that are increasing or reducing oligosaccharides. So genetics, processing, and then of course enzymes are all ways we might be able to deal with these anti-nutrients. And we've already talked about enzyme treatment. That's one way. Fermentation is another way. Now we can, almost all these enzymes are direct application. To my knowledge, and you can correct me if I'm wrong, there's no enzymes that pass through an extruder that I know of. Now there are some enzymes that will go through low temperature pelleting, okay? But for the most part, these enzymes are being added post-processing. So you're adding your phytases, your carbohydrases, your proteases, and that's no different than you top coating with oil. All of us top coat with oil. Well, we can easily top coat with a water soluble, a little bit of water, bring on an enzyme, and then top coat with your oils. It's not that difficult to do, but it's the most practical solution. Phytate's been well studied. There's lots of information out there. There's actually some nice information on how much phytate is in different ingredients. This is an example of Hans Stein's work. But phytase has several reviews. This is one of those reviews. It works across a number of different species. And personally, I think that phytase should be used by all feed manufacturers. This is just an example. We've used a number of different, and I'll show you both fish and shrimp. But again, adding phytase in terms of phosphorus retention, you get an improvement in phosphorus retention. This is with shrimp. We have both protein, so dry matter digestibility, protein digestibility, and then pH is phosphorus digestibility. And so you can see that there's improvement in phosphorus digestibility. And we did this in a fish meal-based feed formulation as well as a 100% plant-based feed formulations, because we thought maybe we might see some big differences across there, but reality is you still have lots of ingredients that have phytase in them in a fish meal-based feed formulation. Again, just showing a growth trial looking at phytase supplementation. Now, what we typically see in a lot of the species that we work with the enzymes, occasionally you do get increases in performance in the laboratory, but mostly it's digestibility. Mostly it's about a 5% increase in digestibility. So we did not see differences in weight gain, which is not surprising, but we did see differences in phosphorus retention. And then we also looked at copper retention, and we did see improvements in terms of copper retention in the animals. And to me, the phytase, it's I've freed up phosphorus, so I can reduce my phosphorus level in my feed formulation. That should pay for your phytase if you properly reduce the phosphorus level. But then you get benefits in copper, iron, a number of trace minerals. And so those are, to me, are the major benefits that you're getting. So again, examples of phytase. This is an example where they're looking at performance in water quality. And there's not a whole lot of these studies, so this is just one example from fish. But they basically use phytase, and again, when they use the phytase, they were able to reduce the total level of phosphorus in the feed. Therefore, you reduce the phosphorus loading to the system. So if you're in a system where government restrictions are on you for phosphorus loading, having a phytase, whether or not you do it through a fermentation process or you do it through direct enzyme additions, is a major benefit for phosphorus loading. So our trout industry, our salmonid industry, where phosphorus is a major issue, the use of phytate is a very big key there. And again, they reduce the phosphorus loading by about 50%, so it's a big decrease. So in terms of bioavailability, of course, you're going to increase phosphorus bioavailability, copper, magnesium, and zinc. In our catfish industry in Alabama and Mississippi in the U.S., they had some problems where they then started using phytase actually because of a disease problem. They were hoping it would help with the disease. But when they started using it, and I don't care why somebody adopts something, they should have adopted it for nutritional reasons, they didn't, but they're still using it for nutritional reasons. But we have not seen, we used to have a problem with what we call no blood, which was probably due to low bioavailability of iron and copper. And we haven't seen it since. And so there's side benefits, so to speak, because you're making your trace nutrients more available to your animals. So it's not just that phosphorus. And then in general, about a 5% improvement in protein digestibility. So again, to me, phytase is something that all of our aquaculture species we should be using it with. Then there's also, as I said, these non-starch polysaccharides. There's not a whole lot of data that at least I've seen. This is one of the few studies that shows our non-starch polysaccharides and breaks them down. But what I want to point out is that, where is it? Stachyos, xylanose is an example here. There's not a lot of numbers on some of these and a lot of different ingredients. But we've done some work where we've looked at some of these carbohydrates that'll break down some of these compounds that may have inhibition on digestion or the absorption of amino acids. So adding some of these carbohydrates is breaking down that non-starch polysaccharides. Now realize that these are not typically at high levels or relatively high levels. So a lot of times when we're adding a carbohydrate, it's not going to improve, at least in my opinion, your energy availability because you're dealing with a very small component. But what you're doing is you're changing, for example, maybe the fluidity of the digestive system, or you're improving digestibility. And it typically happens in other ingredients, such as proteins, right, or improves amino acid availability. So this is some examples. This is in tilapia, where we did a low fiber diet, and then we also did a high fiber diet. So basically we used distiller's grain solubles as a way to increase the fiber content of those diets. And then we looked at supplements to improve that. And, statistically, from a complete statistical standpoint, those two data sets needed to be combined, and there is an effect or no effect of fiber and enzyme, but you can see that there's an improvement in performance, and we also saw improvements in digestibility. But from a biological standpoint, that doesn't make sense to me, and if you look at the data separately, this is the low fiber diets, there's no statistical difference. This is the high fiber diets, there is a statistical difference. So to me that shows that there's a much better benefit when you have these high fiber diets. In this case we're looking at xylanases and beta glucanases being digested in those systems. So we've looked at beta mannans, some proteases, some carbohydrates, some beta xylans, beta glucans. And as I said, in general, we get an improvement in protein digestibility, again, somewhere about 5%. dry matter digestibility, protein digestibility, and actually in this case we got a improvement, not statistically, in terms of energy digestibility. But a lot of times when we're talking about the carbohydrates, we're really talking about a small component of the fiber, so the energy budget is not necessarily going up. You're affecting other things in terms of digestibility. So again, we did this in shrimp, and our thought process, we were going to do the same thing that we did in tilapia, but I'll point out the fact that when we're dealing with tilapia, we're dealing with corn. When we're dealing with shrimp, we're usually using whole wheat, and whole wheat actually has a higher level when we make that switch, and so what we called our low fiber diet actually ends up to be a higher fiber diet from a xylanase standpoint. And so this is the supplementation percent weight gain response, depending on the fiber content. And so you got two different sets there. And so we actually saw better performance in what we thought was the low fiber diet, but because that was higher wheat content, it actually had more xylans in it, so you actually had a better response in terms of the xylanase. So we've seen these carbohydrates work in both fish and in shrimp, but it is matrix dependent. So you do have to have, look at the matrix that you're dealing with and add the appropriate carbohydrates. Now, one of the things that I don't think we have a whole lot of data, this is an example of one of the more recent studies, that people have looked at, phytases, xylanases, proteases, and they've looked at them all independently. And they're just now starting to mix these together to look at what the limitation is or how the different cocktails are going to work. And this was an example of where phytase and the xylanase both work synergistically. And I believe that they looked at protease also in this example, but to me it kind of makes sense that, if I'm given a phytase, and this is very generalization, phytase, a carbohydrate, and a protease, well, if I add a protease, I will get improvement in protein digestibility. But why not add phytase, which gives me that protein digestibility, but it also gives me my mineral improvements? And so adding a protease when I'm using phytase, maybe I'm not going to get a response. No one's looked at these combinations, or there's not a whole lot of data. But as I said, in this example, the phytase and the xylanase worked, and then the combination, I believe, of protease and phytase did not give as good a response. So we need to look at these in terms of matrices and what's there, but they all do work. It's just a question of what you're looking for in terms of the performance. So, as I said, adding enzymes, and realize that if you're doing a fermentation, you're essentially adding an enzyme. You're just creating that enzyme while you're doing the fermentation, or if you're taking an enzyme and directly adding it. This can be done on the feed. This can be done at the feed ingredient level. So some of our newer feed ingredients, they're taking and modifying that product at the plant where they have a lot more control. They can add those enzymes, or they can do that fermentation, and then that product's coming out to the farm, or sometimes the feed mill or the farmer's adding that, in which case we're seeing things work in both cases. But to me, the farmer shouldn't be doing it, the feed mill or the ingredient supplier should be doing it. But they all do work. As I said, I think phytase is well worth the investment. I think some of the carbohydrates are worth the investment. I'm not sold 100% on the proteases. They do work. The question is whether or not they're cost effective, or, as I said, if I use a phytase, do I get more performance if I then add a protease? And that really hasn't been looked at that much. So again, I think these are worth the use. You do have to spend a little bit in terms of the application. And with that, hopefully I've not bored you too much. I told you it'd be quicker. Do we got questions, comments?